All right, Algebra 2, lesson 6-2. Today we're talking about properties of exponents, the harder version. You had almost this exact lesson in Algebra 1. Today's date is Wednesday, December 2nd, 2020. Our objective today is to do what? With a quiet raised hand, I can see all of your screens except for Jenny and Jessica, who need to turn on their cameras, and Jade. Quiet raised hand, who wants to read our objective? There it is, Wyatt.
Use the properties of exponents to simplify rational exponents.
There it is. All right. So first property, x to the power of 0. And again, x can be anything. It could be a variable. It could be x. It could be y. It could be z. It could be a number. It could be 2 to the power of 0, 5, negative 100. It represents any and all things. So another way of saying this property is anything to the power of 0 is what? Hold up the number of fingers. You're either saying it's 0 or is it 1. Anything to the power of 0 is, it's not 5. It's 1. Yes, it's the property that you have to have memorized. So as an example, you could say y to the power of 0 is 1. You could say 3 to the power of 0 is 1. You could say negative 100. As long as there's parentheses around it, the power of 0 is 1. If there's no parentheses around it, then it's negative 1. Because order of operations states you do the exponent first, turn it into 1, then do the multiplying by the negative, and it turns into a negative 1. All right, what about x? Oh, question? Yeah, go for it.
What if it was 0 to the power of 0?
That is called the indeterminate form. That is illegal so far. 0 to the power of 0. It is a type of indeterminate form that you'll see in AP calculus, or just normal calculus too. And the only way that you can get this is with functions, some sort of function that's defined as 0 to over 0. The number 0 to the power of 0 it's not a number. It doesn't exist. But you can have a function that does evaluate to 0 to the power of 0, and depending on how you manipulate that function, it will mean different things. X to the power of negative n. To get rid of that negative power, you can turn this into a fraction. Does everyone remember what that fraction is? Who remembers? Yeah, Charles.
Is it x to the power of 1 over n?
Really close. So you're saying x to the power of 1 over n. It is a fraction, but the fraction is not in the exponent. It is in the base. So it's going to be 1 over x, and then to the power of n. So give yourself some examples. You can have like 1 over 2 to the power of negative 3 turns into just 2 to the power of 3. This is kind of like the reverse rule, right? If I have a negative in the denominator, it just means flip it. So I flipped it and then made it a positive exponent. So this is kind of a really key example that you should probably write down. Maybe you can change the number up. You can say 1 over 3 to the power of negative 4, or something is 3 to the power of positive 4. Just make sure you know that negative power means flip it and then change it to a positive. So if I have, I don't know, 1 over AB, all of that to the power of negative 1, that means this turns into normal AB. Or maybe I have, I can do should I do a really hard example that you guys might not have seen before? Let's try this one. CD to the power of negative 1 is equal to C over D. Why does that work, Mr. Sindel? Did I just blow someone's mind right now? Because C by itself is naturally to the power of 1, so it stays in the top. But the thing that is to the power of negative 1 is just applied to the D. So the D is the thing that flips, and it goes to the denominator, so it's C over D. All right, and some people I cannot see even though your camera is on. Who are you? You are Jade, and you are, I have to rename you Jessica. I can't see Jessica. I see Jessica's fan, which is okay, I guess. I rate it as an 8 out of 10 fan. This next one, x to the power of n times x to the power of m. Does anyone remember what this property is going to state? Jose?
Would you just add the exponents, right?
You do indeed add the exponents. So it would be n plus m. So go ahead and give yourself some examples. If I have 2 to the power of 3 times 2, that's equal to 2 to the power of 4. Why? Because this original 2 by itself is really 2 to the power of 1, and then 1 plus 3 is 4. You can do like fractions too, a fraction one. So let's do, I don't know, a to the power of 1/3 times a to the power of 4/3. This is equal to a to the power of 5/3. You just add 1 plus 4 is 5, and then the denominator 3 is still there, a to 5/3. So I'm making up my own examples. You can make up your own examples too. I'm trying to choose examples that are a little bit harder than you're used to seeing to kind of raise the bar. And that's all of mathematics, right? You've learned something, let's make it harder. Let's make sure you really know what you're doing. Let's raise the bar. All right, this next one is very, very similar. Instead of multiplying the bases, I am dividing the bases. What?
Don't you just subtract the exponents?
You do indeed. So it'd be n minus m instead of the n plus m. Let's do some examples over here. Let's do a to the power of 3 divided by a to the power of 7. If I subtract them, I could say that that's just 3 minus 7. That's a to the power of -4. And then I could go back here and use this property and say, oh, that's 1 over a to the power of 4. That would work too. Let's try another one. I don't know, z to the power, I'm making up stuff on the fly. So z to the power of 13 divided by z. That's equal to z to the power of 12. Why? Because that denominator had a power of 1, so 13 minus 1 is 12. Oh, what just happened? And you could do multiple things too. You could have like an a b to the power of 7 all over a squared b cubed, and you can subtract them at the same time. So this one would be a to the power of -1. I ran out of room here. Let me do it underneath it. That's equal to a to the power of -1, b to the power of 4. You can subtract them at the same time. All right, so these next 3 rules, they're kind of like the distribution rules of your properties of exponents. So I'm going to come over here and do a curly brace. These are kind of like distributing. Distribute. So when I have x to the power of n, which is also to the power of m, what are we doing really? I don't want to call him Wyatt. I always call him Wyatt. Someone new. Sorry, Wyatt.
You never call him. Seriously.
I've never heard Wyatt's voice today. I'm gonna cold call. I promise I will. Fernando, go for it.
Would it be n times m?
It is indeed n times m. See, I knew you knew it. And give yourself a few examples. Let's say a to the power of 3 times, or to the power of 4, just multiply that, it's a to the power of 12. Let's do fractions. Fractions scare people. B to the power of 1/3, all of that to the power of 3. That would be equal to b to the power of 3 over 3, which is just b. Oh, and I guess when I say distribute, that's not really distributing anything. That's just multiplying. These two are multiplying but distributing. So my curly brace was too big. Maybe I'll just move it down. Good enough. These two are really the distributing ones because there's 2 things to multiply into. So sorry about that. If I'm distributing this power of n and I'm multiplying it into each of these exponents, what does this turn into? Andres?
It turns into x to the power of n times y to the power of n.
Exactly, y to the power of n. Notice that this cannot be a plus sign. It has to be a multiplication sign. If it was a plus sign, there's not a general formula for that because this could be any power. It kind of turns into a binomial expansion, which no, we don't touch that until we usually hit pre-calculus, but it's kind of a hard formula. You have to use Pascal's triangle, ascending and descending powers. There's a lot of tricks to do it, but when it's multiplication, it's much, much easier. You just distribute the power. And very similar, if I have a fraction x divided by y instead of times y, what will that turn into? Someone that I haven't heard from, some brand new voice. Sorry, Andres. Sorry, Wyatt. Some new voice. Sergio, you're a new voice.
So it will be x to the power n.
And yep.
Divided by 2y to the power n.
There it is, yeah. Oh, I didn't do examples for these last ones. Let's say, I don't know. This is kind of a really important one because a lot of people, when they see this, they forget how to do this. If I have some number with a variable to the power of, I don't know, 3, you have to cube both of them. This is 2 to the power of 3 times y to the power of 3, which is really 8y to the power of 3. I think that's a super, super important example. I'm only going to do one because I don't think I can fit another one in. And let's try one that comes up pretty often. I don't know, like 1/2 to the power of 3. That one's pretty common too. So what happens here? You have 1 to the power of 3 over 2 to the power of 3, which is really just 1. 1 to the power of 3 is 1 times 1 times 1, 1. 2 to the power of 3 is 8. So 1/2 cubed is 1/8. All right, so those are your rules, and we are going to get really, really difficult with that because we're combining these rules of exponents, which we already kind of touched on yesterday, but with like really hard problems from 6-1. So here we go. We'll start with baby steps.
Okay, I have a question. Sorry, I couldn't
yeah, go
do
for it.
the hand thing. But for the distributing one, for the bottom one, wouldn't you do, so it's 1/2 with power of 3, wouldn't you subtract the exponents?
That is a great question. Does anyone know the answer why you don't just do 3 minus 3 and get 0? Why do you not subtract the exponents? Jose?
Because it's like x and y, so you can't subtract those. Right, so they have to be the same number, right?
They have to be the same base, exactly. So up here, where we had x to the power of n, x to the power of m, we assumed that the top and bottom base number were the same, z and z,
Okay.
x and x. Because this is a 1 and a 2, those are different, so you can't subtract them. Yeah, great question. All right, on to example 4. We have 4 parts. Switch to try the first part of example 1. I want to get into this form x to the power of n. I see one hand. And they're all going to be basically the same thing. So once you get the first one, I think they'll kind of fall from there like dominoes. Wyatt?
I don't know if this is right, but would it be x to the power of -3/4?
That is indeed correct. X to the power of -3/4. Notice that that is in the form that it wants. It wants 1 base, 1 power, and I have 1 base, 1 power. The power happens to be a negative fraction, which is scary, but we're done. All right, well, let's try the next one. It's almost the same thing. I want to hear some new voices. These are getting pretty easy here. Jade.
X to the -7/5.
There it is. Let's try another one. Someone new. Who have I not heard from? Cohen.
X to the positive 2 or 3.
Perfect. And who's it going to be? Either Jenny or Jessica. One of you two. Does someone want to step forward? Try this last one.
I'm gonna just guess, okay?
Okay.
X 4/5.
X to the 4/5. You're right. Yeah, it's exactly like the previous problem that Cohen did, where if it was a negative and it flips up to the numerator, it becomes positive. Perfect. So you have your 4 examples. This was all invoking just one rule. It was invoking the second rule up here. I was about to make a really weird star shape. Yeah, so when you're switching the variable between the numerator and the denominator, just make sure that you switch the sign of the exponent. So let's say sign of the exponent. So if it was a negative, change it to a positive. If it was a positive, change it to a negative. That was the point of me doing example 1, because it's, I don't know, for some reason, I've had a lot of students that mix this up or miss this problem. Getting those two confused. Okay. Example number 2. We're starting to get a little bit harder here, using some more rules. Notice that I have the same base. Y is the base, Y is the base, and I'm multiplying those bases. I'm using one of these rules. Someone help me. I see Wyatt's hand. Who else has a hand? Go for it, Charles.
Would it be y to the negative 2/3? That's what. That's how you say it.
Yep, there it is. You just multiply the exponents. Don't you? No, that's not right.
You gotta put a 1 under the 2, right? And then you just move it over, right?
So negative 2 over 1, and then 1/3. Are you multiplying or are you adding these?
Oh, I multiplied it.
Yeah, so multiplying it would work if it was in this form right here. Ooh, I don't know what happened there. In this form where it's a power to a power. But if it's just multiplying the bases, what should you be doing with these numbers?
You should be adding them then.
Exactly. So if I add them, we can't add them right away because they don't have like denominators.
You gotta, yeah, you gotta multiply the left by 3. So the top would be 6 and the bottom would be 3. Negative 6, sorry.
Perfect. And you
And
get,
then it would end up as negative 5. Y to the negative 5th. Oh, negative 5/3, yeah.
perfect. So let me rewrite this one as y to the negative 5/3. Yeah, nice. And Wyatt, do you still have a question?
No, I was just going to tell you that you were supposed to add. Just trying to get your attention.
Got you. Okay. Well, thank you. All right. This next one is also a little bit difficult because there's fractions, but again, the same rule. I'm going to be adding those exponents. So let me go ahead and set it up for you. I'm going to be adding 2/5 with 4. Why? Because I have the same base, which happens to also be the letter Y. So I need to add 2/5 plus 4. But I'm not going to do that. Someone else is going to do that for me. Still haven't heard from Jessica. She'll eventually participate here. Maybe not in this problem. I've called on Wyatt a lot. I've called on Charles a lot. Not so much everyone else. Anyone aside from Charles and Wyatt? How do I add these two numbers? Jade.
You're gonna put the 4 over 1. And then you're gonna add 2 and 4 to 6. And then over 6. So it just ended up being 1.
1. Wait a sec. If it adds up to 1, if I started with 4 and I added some positive number to it, shouldn't I have a number bigger than 1 or bigger than 4? Something must have gone wrong. Can you call on someone, Jade? What's going wrong here?
I can't see.
We have, yeah, we have Jose, Wyatt, and Charles are raising their hands right now.
Jose.
The denominators aren't the same.
Ah. Yeah, the denominators are 5 and 1. So how could you make the denominators the same, Jade?
Multiply 4 by 5? I have no idea.
Yeah, 4 times 5 times 5. So our new equation our new expression rather becomes 2/5 plus 20/5, which is
22/5.
22/5. So our answer up here is y to the power of 22/5. Nice. Yeah, question, Sergio.
Oh, never mind.
No, okay. You're so excited though. You're like waving around. By the way, we do have a quiz tomorrow, just as a heads up. My calendar was off by 1 day. I'm moving on unless someone shouts at me or has a question. Moving on. And all right, example number 3. Oh, we're getting harder and harder. Like, I mean, look at this. Look at example number 6. Look at example number 7. We're getting really hard down here. So we're still taking our baby steps. Let's see how we go. Example number 3. What am I going to do here? Okay, well, Wyatt and Charles again have their hand raised.
I think I'm just gonna leave my hand down.
Well, you can keep raising it. I'm not going to call on you for this problem unless no one else is. I don't want to know what the math is. I just want to know what rule am I using? What rule do you see up here? You have 1, 2, 3, 4, 5, 6, 7 different rules. You got a 1 in 7 chance if you just blindly guessed. But again, take a look. What rule do you think you're going to be using here? We'll give it to Jose.
You'd be subtracting, right?
Yeah, you're subtracting these powers. This 3/5, I'm going to subtract the 7/10 because I'm dividing the common bases. So let's go ahead and write it out. Down here, I need to do 3/5 minus 7/10, and I can't do that. So someone help me. Yeah, Andres.
Would you multiply 2 by 3/5?
Yeah, so 2/2, right?
Yeah,
and you get the new equation 6/10 minus 7/10, which means
you subtract.
Yep, you're subtracting. You get w to the power of
-1/10.
Negative 1/10. And you might be thinking, oh, isn't there a rule that makes this negative into a non-negative? And you're right, but look, it wants the form w to the power of n, and it's w to some power, so we are done. W to the power of -1/10. If in the instructions, it won't happen today, I don't think, on Khan Academy, but maybe in the future it'll say, write your answer with positive exponents only. Then you'd have to change that negative into a positive by using another rule, but we're done. All right, on to the next part of example 3. What am I doing here? It's probably the same rule. I mean, it looks the same. It's w divided by some other w. What do I do though? And I'm gonna forcefully call on Jessica because I haven't heard from you and I want to hear from you. Tell me anything about this problem.
Which one?
W divided by w to the power of 1/3.
I don't know.
So in the previous example, I had w to the power of 3/5 and w to the power of 7/10, which maybe was a little bit harder. And notice what we did with the powers. The powers over here, we did 3/5 minus 7/10. The key being we are subtracting them. So do you think we're going to be subtracting them again, or are we going to be doing something different?
The same thing.
Same thing, yeah. So what are we going to be subtracting? Because I don't see anything here. Is it a 0? Is it a 1? Is it something else?
A 1.
It is a 1. So I'm going to be doing what subtraction problem then?
1 minus 1/3.
There it is, yeah. All right, Jessica set it up. Someone else, how do we do that? How do we do 1 minus 1/3? And you might just know it off the top of your head. Oh, well, that's blah, blah, blah. Or maybe you want to show your work and tell us exactly how you got that. All right, Wyatt and Charles have been waiting patiently. We'll give it to Wyatt.
So the whole number 1 is also the fraction 1/1, and we need to have common denominators. So if we multiply the whole thing by 3 on the numerator and denominator, we'll get 3/3, and 3/3 minus 1/3 is 2/3. So your final answer will be w to the power of 2/3.
There it is. Thank you. All right. On to example number 4, which in my opinion is even easier than example number 3. Adding and subtracting fractions is much harder than multiplying fractions. All right, so example 4, I have a to the power of 3/7 to the power of 2/3. What do I do? Go for it, Charles. I think you're muted.
Okay, but so you're multiplying the powers. So 3/7 and 2/3. Then you can cross cancel both of the 3's and they will end up both equaling 1. So then you just have, then both of those are 1, so you just kind of shift the 7 over under the 2.
Cool. So the final answer is a to the power of
2/7.
2/7. Perfect. And we'll explain it too. I like the shortcut of being able to cross cancel. Oh, are we out of time? No. Julian.
No, we have
hello.
10 minutes.
Is that
I
actually
have a
Julian?
question. I got lost.
How are you doing, Julian? He's just gonna mute. Okay. Well, I guess we'll continue. Cohen, what happened to your video? Anyway, if you're actually lost, Julian, welcome to Algebra 2. This is a to the power of 1/4.
Classroom.
What class are you supposed to be in?
I'm supposed to be in
Uh-oh.
Though I miss you.
I miss you too, Julian. I'll see you probably soon though, right? You're coming back in January, is that right?
Yeah, that's the plan.
Cool. Yeah, I look forward to seeing you then. But I'm probably going to continue on this lesson, so I give these guys time to do some homework, hopefully.
Oh yeah, sorry, my bad.
You're good, you're good. All right, so a to the power of 1/4 to the power of -3. Obviously, we're multiplying 1/4 times -3. Someone else do this for me. Okay, we're going to go rapid fire here. Yeah, Jose?
So would that just be -3/4?
Exactly, yeah, because it was over 1. 1 times -3 is -3. 4 times 1 is 4. So yeah, just 3/4, -3/4 is the power. So a to the power of -3/4. And we're done. Okay, thank you. Next, example 5, slightly harder. These are the types of problems that you're really going to be facing on Khan Academy. So we need to be paying lots and lots of attention. I see an afro. Is that Andres? That is
Yeah,
Andres.
wait, Mr. Sando, I have a question.
Yes.
So for example number 4, the second one, you don't need to make common denominators, right?
No, and same thing with example 4 for both problems.
Yeah, for both.
Whenever you multiply fractions, just multiply them. They're even easier.
Okay.
Yeah, good question. All right, example number 5. We need to rewrite this in the form k times z to the power of n. Notice that I have a radical. It's not in exponential form, but we know how to convert from a radical form into exponential form. So that should be our first step. Let's go ahead and rewrite. I'm going to rewrite the 15 out front. The denominator is still going to be the same. I'm going to rewrite 3z to the power of 5. By the way, if you're in college, they'll pronounce this z. 3z to the power of 5, because z and t sound too close together, especially for those college professors that have a thick accent. So this z to the power of 3 that's being fourth rooted, I need to convert that into exponential form. How? Show me that you did the homework last night, or at least pay attention in the lesson yesterday. How do I convert the fourth root of z to the power of 3 into exponential form? Andres.
Okay, so I think it's 15 to the power of 3 or 3/4, I think, or not.
Yeah, z to the power of 3/4. Yeah, nice.
Z. Yeah, it's my bad.
There it is. And let's go ahead and simplify the coefficients. 15 divided by 3, those they don't cross cancel, but they simplify. So 15 and 3 turns into what and what? How do I simplify 15 over 3, Charles?
5 and 1. So 5 would be top, 1 is bottom.
So 5 and 1. And then what do I do with this z to the power of 3/4 and z to the power of 5? Someone else? You've seen this before. When I have the same base and same base, but I'm dividing them, what am I doing with their exponents? What?
Would you subtract them?
You do indeed subtract them. So this will be z to the power of 3/4 minus 5. And we need to do some scratch work. What is that? 3/4 minus 5 over 1. And I'm running out of time. I have to just kind of rush through this. Sorry, guys. Multiply the top and bottom here by 4. And I'm going to get 3/4 minus 20/4. Now that I have like denominators, 3 minus 20 is negative 17. Denominator is still the same. And our final answer, I'll write it in red, because why not, is 5z to the power of negative 17/4. Final answer and box it. Definitely box it because there's a ton of work that's happening here. Should have boxed this last one too. There's work that was in the way. Yeah, a little bit harder. Let's go a little bit harder still. And I now have to rush through this, and I apologize. If you can keep up, that's awesome. This is the reason why I wanted you to not take notes, is because I can just rapid fire do this and you just pay attention. So pay attention more so than writing it down. You can write it down later if you need to. I'm going to rewrite the cube root as the power of 1/3. So this is going to be, the inside is still going to be the same. Let me choose blue here. It's still going to be b to the power of 2/5 on the inside. It's still going to be times b to the power of 1/4. That hasn't changed. The only thing that's changed is this cube root is now the power of 1/3, which you should have remembered from yesterday's lesson. I'm now going to distribute this power of 1/3 into each of these fractions. Distributing means multiply. Multiply is super straightforward. You just multiply straight through. So this is going to be the b to the power of 2/5 is now b to the power of 2/15. 1/3 times 2/5 is 2/15. And this is times, and there's another way to do this. There's two ways to do this. I'm doing it maybe the longer way. B to the power of 1/12. From here, I need to simplify even further. I need to add these exponents, 2/15 and 1/12. It's not a fun problem to do. And I should have done it a little bit differently, but let's do this long way. 2/15 plus 1/12. I need to get like terms. Yuck, that is super gross. I changed my mind. I don't want to do that long process. Gross, gross, gross. Back out, back out. Undo, undo. I'm first going to add these and then I'm going to distribute. I don't want to distribute too early. I'm sorry. You can do it that way. I don't like adding those fractions. They're way too hard. I'm going to add 2/5 with 1/4 first. 2/5 plus 1/4. I'm going to multiply by 5 over 5 for the 1/4. I'm multiplying by 4 over 4 for the 2/5. And my new equation is 8/20 plus 5/20. Guest star Mr. Warner in the background. He says hi. 8 plus 5 is 13. So our function is now going to be b to the power of 13/20 to the power of 1/3. Multiply the 1/3 in, and I get b to the power of 13/60. So if you added these two together over here, you would have gotten 13/60, but that wasn't that fun of a problem to do. So here's our final answer, and we box it. And I have exactly 1 minute and 40 seconds to do example 7. Sorry, I'm rushing through the end here. Hopefully you're just paying attention and not writing this down frantically. Writing it down frantically is not going to get you to learn this. So very quickly, I'm going to convert this from radical form to exponential form first. I have 27c to the power of 5/7. That's the conversion. And this is still all to the power of 1/3. I am now going to distribute this 1/3 power into each of these two terms in here. 27 to the power of 1/3 is really, I'll just write it down. 27 to the power of 1/3 is right there. And it's going to be times c to the power of 5/21. So 27 to the power of 1/3, I can simplify that because 27 to the power of 1/3 is really, my watch is yelling at me, you have a minute left, is really the cube root of 27 times c to the power of 5/21. The cube root of 27, I mean, I have it on my wall, but you can't see. The cube root of 27 is 3. So it's 3 times, or I guess just 3c to the 5/21. And that is our final answer. I box it. We have exactly 30 seconds left. I know you guys are trying to write stuff down. Can you guys really quickly give me a fist of 5? How well can you use the properties of exponents, especially on like example 6 and 7? How well do you think you can do those? I'm seeing 3s, 0s, 4, 4, 3, 4, 3, 3. Cohen and Jessica. I do not see a number. Cohen and Jessica. Cohen's head popped up. 4, Jessica, 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 Jessica. 3. All right. That concludes our lesson. You guys are officially dismissed. Good luck on
Thank
the
you, Mr.
homework.
Snow. Thank you. Thank you for being so hardworking.
Thank you, Mr.
Tomorrow's a
Snow.
quiz. We'll see you guys tomorrow. If you have questions on the homework, tomorrow's a good time to ask.
Oh, can you post the homework?